Let's look first at the basic equipment that the operator has to use. There's a power unit which drives a spool carrying anything up to 25,000 feet of steel wire. Plus a range of tools and some special tubing to act as a pressure chamber while the tools are entering the well. For offshore work, the complete wireline layout also includes a fitted workshop holding the standard downhole tools. Any extra equipment can be flown out from lower stock as the need arises on the platform. Step one in a wireline operation is to position the equipment, and that's a job normally done by the platform crane. Power for the whole operation is provided by a diesel engine driving through a hydraulic unit to a 4-speed gearbox, which allows the operator to pull the wire onto or off the spool at a slow crawl with a quick acceleration up to 60 miles an hour if the need arises. The wireline itself varies in thickness depending upon the specific job. The most common is 90 thou, and it's passed around a measuring wheel to give the operator a clear indication of depth during a downhole run. So that is the basic setup: the power unit, the wire, and the tool. Let's look for a moment at what is probably the most typical wireline operation, removing that subsurface safety valve. It's a job that has to be done not just for maintenance, but if you think about it, it's the only way that tools can be passed further downhole. Okay, the first question is, how do we get the tools into the well, bearing in mind that the pressure inside is high? Now, beneath the main deck are the well heads, each topped with a unit commonly known as a Christmas tree. The technique used to gain access to the well is straightforward. First, close the Christmas tree valves, bleed away the internal pressure inside the tree, then remove the cap, and finally stab on what's known as a riser. From here on, the risks are quite high, so the amount of care matters a great deal. It's extremely important to make sure that the wireline team have control of the pressure inside the well. To do that, the blowout preventer is fitted. Inside its forged body, the preventer has hydraulic rams which close around the wire but can be opened to pass the tools into and out of the well. Of course, if an accident happens, the operator can close the ram to seal the well. Each preventer is tested before every downhole run using available wellhead pressure. The next job is to fit what's known as lubricator tubing. Screwed together in sections, this tubing, with the completed tool string inside, will be fitted to the top of the blowout preventer, rising to a height of 20 or 30 feet. Its function is to act as a pressure chamber so that the well can be opened to accept the tool string. Now, at the very top of the lubricator sections is this unit, known in the trade as a stuffing box, and let's for a moment concentrate on this bit of it. Its job is to seal off the pressure inside the well at the same time as allowing the wire line that is, to pass in and out. And that seal is achieved by screwing down on this packing nut here, forcing 7 rubber rings tightly against the wire. It really is a very simple but very effective way of going about. The wire runs from the main drum around a pulley at the bottom of the blowout preventer, upwards around a second pulley on top of the stuffing box, which is, remember, on top of the lubricator section. But let's go on now to what actually goes on the end of the wire down the hole. Essentially, it consists of a set of devices that together make up what's known as a tool string. The tool string is joined onto the end of the wire by means of a rope socket. Essentially, you pass the wire through and then form a knot. It looks very simple, but I'm told that actually getting your knot neat in the wireline business is something of an art. But how does the operator actually control a tool string that's 2 miles down a hole on the end of a length of wire? Well, he does so by using a hammer action in the tool string itself, which has 2 main parts. There's the top end, or stem, which is essentially a weight, normally about 5 feet long, weighing about 50 pounds. This is rather smaller, so I can handle it easily. And it has 2 main functions. It has to deliver sufficient weight or pull to drag the wire through the seal in the stuffing box, It also acts as a hammer. It can be raised, lowered again to deliver the hammer blow. Although the hammer blow itself is actually delivered by the bottom end of the tool string, known as a set of mechanical jars. It's rather like elongated chain link, somewhat squashed on the outside. What the operator does is to raise the wire, open the set of mechanical jars, and then at precisely the right moment, lets the wire go, delivers his hammer blow. Again, looks very simple. The skill, of course, lies in knowing precisely when to let that wire go. Before we look at how the hammer blow is actually used, let's look at the very practical problem of getting that lot down the hole. First, the complete tool string is pulled into the lubricator section. Care at this stage is important because of the wrist of the wire. It's more than strong enough in a straight line, but kinks can cause it to break fairly easily. The next step is to pressurize the lubricator sections to match the pressure inside the well. Now, what you don't do is to open the master valve in the Christmas tree, because if an untested connection failed up in the lubricator, then the well pressure could blow the whole thing off in a split second or so. So the technique is to slowly pressurize the lubricator by using gas from another well, and then each seal can be checked as the pressure rises. Once that's done, then the master valve in the Christmas tree is opened, the tools can pass down the hole. The job, remember, is to remove the subsurface safety valve at around 300 feet below the platform. The actual tool depth during the run is shown on an indicator in the control cab, and apart from weight measurement, that is the only real guide the operator gets as to what's actually happening below him. Now, if you could see the action, it would look something like this. On the end of the tool string coming down towards the valve is the pulling tool itself. It locks onto the top of the subsurface safety valve like that. While down here on the valve itself, the sealing mechanism has to be released. What happens simply is this. The V packing here, there's one set here, one lower down, energized by hydraulic oil, relaxes to match the well pressure when the oil is bled back to the tank. The dogs holding the valve in position will be drawn in like this when the pulling tool lifts the neck. But the packing holding the ball valve in place is still very tight. It won't come loose on its own. It has to be jarred free. Now, below a certain depth, the operator can use the driven spool to jar it loose. But when the depth is between 300 and 2,000 feet, it's normally impossible for the operator to react quickly enough to prevent snapping the sensitive cable up here. So the job has to be done by hand. And when the valve is clear, the operator can pull it up into the lubricator, taking a lot of care in tight areas, like the Christmas tree. And then, once the Christmas tree master valve is closed and depressurized, lubricator can be lifted off, and the valve transferred to the workshops for maintenance. With the valve out on the workbench, it's possible to see how it actually works. Basically, it's a fail-safe principle. Apply hydraulic pressure, the ball opens, and the gas or oil flows. Shut off the hydraulic pressure, intentionally or not, by accident, and the ball shuts, sealing off the well. Right, think back for a moment to the hammer action we saw with the mechanical jars. That's how the valve is put back into the well. What happens is this. The safety valve, and this is just the top section of it, this time is connected to a running tool by a large brass pin passed through them both. The dogs on the valve body are held in the withdrawn position by 4 steel shear pins, and the whole assembly, the tool string, complete with the safety valve on the bottom, is run back into the hole. Then the operator has to carefully jar it into what's known as the landing nipple without shearing any of those pins. This is where the skill comes in, because when, and only when, those dogs are in position against the matching profile on the tubing, must he jar down hard to shear those steel pins. So, the weight bar falls, the mechanical jars deliver their hammer blow, the pins shear, the dogs bring into position, locking the valve safely in place. All that remains is to withdraw the running tool. An upward jar shears the brass pin, and out comes the running tool. So there's the valve, drawn, overhauled, and put back in place. All that remains is to clear up the mess on the platform. But of course, maintaining the safety valve is only one of a whole range of jobs. There are plenty of others. Like, for example, replacing a worn bottom hole choke. This one was installed just 3 or 4 months ago, and compared with a new one, you can see the amount of wear in a relatively short period of time. Then there's this wicked-looking instrument known as fishing spear, not for sharp, but broken wire. It does happen, not too often. But imagine the situation. Somewhere in 6,000 feet of well tubing, there is a tool string and a length of broken wire. The spear is used to remove the wire so that the tool string can be brought up with a fishing tool. But how do you know when it's all out? And you do need to know, because if a second tool string is sent after the first, broken wire tangle and make the problem a lot worse. So what's the answer? Well, the answer is these two, a blind box and a lead impression block. What you do is to send down, first of all, the blind box and literally smash it down on top of the rope socket, hopefully breaking off the wire. Then, to find out what's happened, you send down the lead impression block, rest it on top of the rope socket, tap it down once gently, recover it, and there on the bottom surface you can see an image of what's happening down the hole. The rope has been broken off. You get a clear image of the top of the rope socket. You can then send a tool, fishing spear down to recover the wire, and a fishing tool down to recover the tool string. So, if nothing else, you could say that wireline techniques are inventive and very skillful. It's certainly true to say they're absolutely essential for the continued operation of any oil or gas field.